So the full chain is bro. Hello everyone, Bubu here. I am a programmer and a DJ from Romania, and I'm really happy to start this new series on TidalCycles because for the past few months I've been playing with it and I've been trying to create some music. We're going to start from beginner level and the approach is very hands-on. I learn by trying things and messing up with them, trying to fix them and then understand why they work, or if they don't, why they don't. So that's exactly what we're gonna do. And of course share all the Haskell headaches we can get. Actually, I think this is a great opportunity for everyone to discover how nice Haskell can be, and if it can be fun anywhere, this is the place. Alright, so let's start. What we're going to do today is just to walk over the setup and explain a bit how timing works in TidalCycle, and get our first contact with the syntax. So in this tutorial, I don't want to explain everything. I want to show you how things behave first, and we are going to look at the setup and focus on how time works in Tidal, how things are getting to be played. I am starting here on the official TidalCycles page to walk you through the documentation a bit. So going to the documentation, you will also see the installation guide for whatever platform you're on. I use Mac OS, and what I did was basically to just follow the steps over here. Alright, Tidal can seem a bit overwhelming at first because of this setup, because it's not just a tool. Tidal is actually a programming language, a DSL, which works on top of Haskell. If you're not familiar to what a DSL is, it is the abbreviation for domain-specific language, and it's just a language with some functionalities related to a domain, and in this case it is obviously music related. This setup contains multiple tools. Each tool does something. You can see them here. There are a few things to install, but instead of going through all of this, let's simplify it and make the first contact. On the left side of my screen I have a text editor. This is called Pulsar. You can also see it here in the installation steps. This is where we are going to write the code. I will write a line which you totally don't need to understand now, just to see what happens. I will run this line or evaluate it by pressing Shift Enter, but nothing happens. How do we know that nothing happens? Here on the upper side of my screen I have a visualizer called Minimeters, which helps me see the waveform coming out of this program, but nothing really showed up here. And that's expected because right now we've only written instruction. Tidal itself doesn't make sounds. So to actually play the sound we need something which can play the audio, and that tool is SuperCollider. You can also see it here. So TidalCycles sends instructions and SuperCollider turns them into sound. And to start SuperCollider, you only have to do this once per session and then leave it running in the background. I will do it now. This is how SuperCollider looks like. It has by default a startup file which runs whenever you open it, but the first time when you open it, that file doesn't exist, so you can go to Start Tidal and get it from here. I will just copy paste it and go to File, Open Startup File, and it's already here. Mine, it's exactly what's here, but I will delete and paste it just for you to see that it works. To evaluate everything, I am using Command Enter, and to see if everything worked, we can go here to Post Window, and there are no errors. So now, going back to the text editor and evaluating again this line, we should see a sound coming out. Alright, so going really quickly again over the setup, we write code in here, in Pulsar, then Tidal understands it as musical instructions, and then SuperCollider take those instructions and turn them into sounds. Now, everything in Tidal is driven by a clock, and this clock is always running. And Tidal doesn't think in seconds or milliseconds or bits per minute as we are maybe more used to, but it divides the time into chunks called cycles per second. The method which does that is called setCPS. So if we set this to 1, then we will have 1 cycle per second. I will set it and play the sound again, and we would expect it to play each 1 second. Yeah, pretty much. I will play a bit with this method, set CPS, to see what changes. I will set it to 2, and you can pause here to think for a second what this would mean for my program. This is 2 cycles per second. So am I going to hear this sound slower or faster? Alright, that's faster because there are 2 cycles per second. So in 1 second, there are 2 cycles, so this specific line is evaluated twice. Now let's set it to 0.5 to see what happens, but this is a bit intuitive. It will play slower. That's because 0.5 cycles per second means actually 1 cycle is spread across 2 seconds. Alright, now that we have a better understanding of how timing works in Tidal, I propose you to try to understand what this line does. This is the hello world of TidalCycles, and I am going to start from right to left. Let's change it here to BD. Alright, when I play this, you can see here, as we discussed, that there is a sound played each cycle. This sound is actually coming from a sample, from a file, from a sound file, and the name of this sample is BD. If I change this to another name, then I will get another sound. Alright, but as I said, this is a file and you can find it on your computer. When you installed SuperCollider, you also got this SuperDirt sample library. So whatever samples were in this now are also on your computer, and you can find them by going to a folder path. In my particular case, to find it, I am using the SuperCollider logs, and the path file should look something like this. There is this application support folder, which should be on all computers if I'm not wrong, and then go to the SuperCollider and downloaded quirks. Alright, so here I am in the library folder from my user. Go to application support and search for the SuperCollider folder, downloaded quirks and dirt samples. Here in the dirt samples you can find all the samples. Let's search for that BD we are using, which comes from bass drum. Here it is, and we see that it's actually a folder. Let's switch it here also. Let's look into this folder. We can see there are multiple WAV files. That's because this syntax here is basically just saying to take the first one that it finds in the folder. If we want to get other samples from the same folder, we can use their index. So the first one will be 0. And it will get the first sound, but we can also take the second one or the third one and so on. There is not much difference that you can hear, but you can see it here on the waveform. So yeah, basically you are just saying here the name of the folder that you want to choose samples from, and then choose the exact sample using its index. Let's try another sound. We can take, I don't know, for example, this one, BAA. Okay, so that was a sheep sound, and we can just find other samples in this way. So this BD is just which sound do I want? What is the file that I want to use? Now, this by itself doesn't do anything, it's just a word. But to turn into something musical, we use the function sound. This sound function, which is also equivalent to writing just like S, means create a pattern that plays this sample. So now you don't just have a name, you have a rule which tells you each cycle play BD. But this doesn't go anywhere. If I just try to evaluate this as it is, it won't do anything. And to actually hear it, I have to send it to a channel, and this is D1. You can use multiple channels, and that means these things are going to play on top of each other. So if I use another sound on second channel and play this and then this, you will hear them playing at the same time. Alright, so if we can make an analogy, this D1 would be like a track in other DAWs. Now, this $sign is just a way of connecting what's on the left with what's on the right. These are also functions implemented in Tidal, and this is the Haskell operator for function application. So this is a syntactic sugar. We basically just say apply this function to whatever goes on right. So the full chain is you get the sample name, then you get the pattern, then you assign it to a channel, and then SuperCollider knows how to read this and turn everything into sounds. All right, so I hope this was clear. This is the very basic. Next time we're going to jump onto a little bit more elaborated stuff. So yeah, stay close. Alright, so this was pretty much it for the day. This was an overview of the setup, how timing works in Tidal, and understanding the hello world of TidalCycles, that simple line. And if you liked it, subscribe to my channel. This really helps me to do these videos. And stay close. Thank you so much.